Lesson 10-2, area of triangles, and in this lesson you learn to find the area of triangles. When are you ever going to use this? You can use the area of a triangle to solve problems in navigation and architecture. So sailors have told stories of unusual occurrences in the area known as the Bermuda Triangle. This imaginary triangle has Melbourne, Florida, Bermuda, and Puerto Rico as its vertices as shown in the diagram. So this is Melbourne, Florida right here. This is Bermuda and Puerto Rico. Okay? So what is the area enclosed in the Bermuda Triangle? And we will find the area of this triangle when we go to example 3. So to find these other questions, you need to discover a formula for the area of a triangle. And we're skipping the mini lab because we are going to now compare these two triangles and see how they compare to the area of a parallelogram. So if I get these two triangles, the black triangle, no, not that one, okay, the black triangle and the blue triangle, okay, and I put them together, if you notice, it forms a parallelogram. So if I take this out, okay, if I take out the blue triangle, nope, not that one. Let me just lock that thing so it doesn't move. There you go. Okay. So if I take out the blue triangle, okay, uh, and I just find the area of this triangle, the area of the triangle is actually half the area of a parallelogram. So this is our parallelogram right here. Okay. And if you notice, if I am going to make a parallelogram, oops, not that one. Okay. Right here. Okay, this is how our parallelogram would look like. There you go. Okay. So in our area of a parallelogram, our area of parallelogram is equal to base times height. And if I take out, okay, one of the triangles in my parallelogram, okay, the blue triangle, if I take it out, okay, the area left will be 1/2 of the area of a parallelogram. So basically, this area of my triangle now, okay, will just be equal to 1/2 the area of my parallelogram, or 1/2 times the base and the height. And that's how you find the area of a triangle. Okay, by getting the area of a parallelogram, we know for a fact that in a parallelogram there are two triangles. Okay, and if I only get the area of one triangle, it will be 1/2 the area of my parallelogram, or 1/2 base times height. And this is where we are. So a parallelogram can be formed by two congruent triangles, the orange triangle and the white triangle. You know that the area of a parallelogram is base times height. The triangles have the same area, so the area of the triangle is 1/2 base times height. So we go to our definition of the area of a triangle. Area of a triangle equals half the product of the length of the base and the height. Now again, going back to what we learned in the last lesson, height and base are always perpendicular to each other, or they form right angles. Okay, so to be able to find your height, you need to be able to find the line that is perpendicular to that line. Okay, so in symbols, area of a triangle is equal to 1/2 BH. Okay, and let's see how this works. Example 1, we want to find the area of that triangle, and the area of that triangle is given as 10. Sorry, the base is given as 10, and the height is perpendicular. The length 6 is perpendicular to the length of 10, so that should be the height, and 10 should be our base, and we substitute base and height to our formula, 1/2 times 10 times 6. Okay, that will give us basically 5 times 6, because 1/2 times 10 is 5, multiplied by 6 is 30. Or we can also do, okay, we can multiply 10 times 6 first and multiply it by 1/2. 10 times 6 is 60. Multiply that by 1/2, it's still 30. Or we can do 1/2 times 6 first, which is 3. multiply it by 10, which is 30. So we can do this because of the commutative property of addition. So it doesn't really matter what numbers you multiply first. You can multiply 1 half by 10, 1 half by 6, and then multiply it by the next number. Or you can simply go from left to right and still get the same answer. So the area of this particular triangle is 30 square units. Again, area is always denoted as square units. Okay, let's take a look at the example number 2. The base is 28 centimeters and the height is 17. Now, if you notice, they looked for a line that is perpendicular to the base because that's what the height is. Okay, and there's a misconception that this is your height. Okay, that is not the height because it is not perpendicular to the base. This is your height. Okay, because 17, okay, the length of 17 is perpendicular to the length of 28. Okay, so going back here, area again, write down the formula, 1 half base times height. Substitute the values of base and height to your formula, 28 and 17. So in this case, we multiply 1 half times 28 and multiply it to 17. Again, we can use a calculator for this one. Okay, 1 half is the same as 0.5. Multiply that by 28 times 17 will give you 238. Or, okay, the area of this triangle is 238 square centimeters. Okay, let's take a look at example number 3. Refer to the beginning of the lesson. Now we want to find the area of the Bermuda Triangle. Okay, so let the base be the distance from Melbourne to Bermuda. Okay, and let's take a look at this one, which is 1,150 miles long. Then the height will be 756 miles. So base is 1,150 and height is 756. Let's go back to this one, and there you have it. This is our base, and this is our height. 950, okay, is not important in finding the area of a triangle because 950 is not the height. So we need to specifically look for the height and the base to find the area of our triangle. So going back here, and let's light up everything again. Okay, or down here. So the area is equal to 1 half times base. Write down the formula. Substitute the values of base and height, 1,150 and 756 respectively. Let's use a calculator to solve this. It ends up with 434,700. So that means the area of the Bermuda Triangle is 434,700 square miles. Okay? And that's the end of our lesson. The secret word for this particular lesson is bamboo. Secret word is bamboo. Thank you for watching.